We're at Devoxx Belgium 2018, and I'm really pleased to be joined by Alasdair Collinson. Alasdair, thanks for coming along and joining us today.
Thanks for asking me.
So I've seen you around a lot recently at various events, and but this week's something new. I've seen you talking about quantum computing in recent times, but you're here talking about functional programming in Java.
Exactly, yeah.
So I know you did a session yesterday. Tell me a bit more about that.
Okay, so I mean, functional programming, for me, functional code has three main aspects. It's declarative, which means you tell the compiler what you want to do rather than how to do it. It uses pure functions, so the output of a function depends only on the explicit input, not on any global state or anything like that. It has no side effects. And you use immutable values. So values are replaced, possibly, but not changed. And these three aspects can actually make code much easier to read, to understand, and to reason about. And from what I've seen, many people still have problems grappling with what functional programming actually is and how it can help you. So I thought I'd give an introductory session explaining what I've experienced and how people can use this in their everyday coding experience.
And I know there was a lot of interest pre-conference. You see the little tick boxes and beer markers on the schedule beforehand.
Yeah,
so I'm presuming you had a lot of people come along.
Quite a few, yeah.
What are some of the common challenges that people really would face looking at functional in Java?
Well, number one is that often there's just a lack of understanding. Functional programming is different to procedural programming, to object-oriented programming. It can work together, but many people just haven't learned about what it is and how it works. The other thing is something I like to call lambda mania, where people try to solve everything using lambdas and streams. And lambdas and streams are really great tools, but like anything else, they're not silver bullets, and there are problems that you simply shouldn't try to solve with them. Finding the right balance isn't always easy, though.
Yeah, yeah. And there must be some common mistakes that people make, apart from just trying to solve everything in those ways that you just mentioned. What else do you see?
Well, basically, many mistakes I see nowadays are actually based on not using functional programming. Having functions that have side effects. I mean, generally, side effects are necessary. If you don't have any side effects, then your program won't do anything. It can't take any input, it can't give you any output, so that's useless. But you want to have your side effects in very clear places in your code. You want to make it very obvious where they happen. And often that doesn't happen in the code that I see but haven't reviewed myself. And also, mutability can often be a problem. Java has call by reference for objects. And so you get the object, your input object, and you can modify it in your function. And it may not be obvious to the caller that that has happened. And that can cause some really confusing problems.
And you talked about breaking this down into three elements in terms of declarative, using pure functions, and immutability.
Yes.
What tools and libraries are out there that can be used in each of those areas?
Well, I'll start from the back. For immutability, if you want to declare your own objects, there's a great tool called Immutables, which is basically an annotation processor. And you define an interface for your object, and it will then generate the class which is immutable, which has loads and loads of protections built in. You can style it a bit to your individual needs. But that can save a lot of time and protect you from a lot of errors you may make. Also in that area, since we do depend on some classes that we don't want to write ourselves. A really big one is, well, the collection framework in Java. The collection framework, by default, is mutable. And that can be very useful, but if you want to have truly immutable objects, and you have, say, a list in there, then the list is mutable. Immutables actually creates an immutable copy, but that doesn't translate to the interface. So you think you can still mutate the list, and instead you get an exception at runtime. What you can do there is use a library called Waiver. And I mean, Waiver is an amazing library in general. One thing that can get you hooked is it brings new implementations of the standard collections. It has its own list interface, its own map interface, and and all of the collections and implementations that back them. And that allows you to truly have an API that makes obvious that no, you can't mutate this, but you can get a copy. And you can work with that. And that will save you from a lot of stuff. Waiver in general can also help with the declarative style. It can make that easier in many ways. And there was actually a talk also yesterday about exception handling with Waiver. And that shows much, much more that library can do, though that still is only a tiny part. As to pure functions, I haven't found anything yet that really has worked for me, sadly. I did recently see a library called Pure4j, which in one case complained about something being mutable, which I don't think was mutable. I haven't yet decided whether I'm wrong or the library is. But that's also an annotation processor. Java doesn't have a real support for pure functions. Other languages do. I don't think we're going to get it in Java, at least not in the way that languages like Haskell have it, simply because that's not how Java has worked traditionally, and Java has to stay backwards compatible. But who knows, maybe we'll get something there.
Well, there's a challenge for the folks at home, which is if you know what can help Alasdair out, give him a shout.
Absolutely, yeah.
Last thing, looking through the schedule here this week, there's a lot of functional talks for a Devoxx conference. You know, it's like, this is the shiny new.
Yeah,
Why
absolutely.
do you think that is?
I'm not quite sure. I mean, functional programming has been around since, I think, the 1960s or something, with Lisp. It was, I think Lisp was the first functional programming language, at least the first one I can think of. And it's had a certain upsurge in the last, well, generally speaking, in the last decade, I would say. A lot of new functional languages have appeared, such as Scala and Clojure, which is a version of Lisp, or Frege, which is a Haskell derivative for the JVM. Since Java 8, we have lambdas, which makes functional programming in Java so much easier. And now that Java 8 is being phased out, actually, by Oracle, I think we're getting to a point that people have worked with lambdas, they kind of understand them, and they want to learn, you know, what's next, what can you actually do with this? And all of these functional programming talks, especially in combination with the whole reactive movement, I think indicate that there's a lot happening to bring Java further into the functional world, not so much from a language perspective, but from a usage perspective.
Cool. Alasdair, thanks so much for joining us.
Thanks for having me.
Have a great rest of the week.
I'm sure I will.
Thanks very much.
Thank you.